The challenge for owners, engineers, and contractors is to assess the performance of the geotube in containing solids while allowing the water to permeate through the geotube's geotextile skin. To assist in determining this performance, Muratech has developed the hanging bag test. Conducting this test properly will greatly enhance preparation for a successful dewatering project. Conducting the test does not require special equipment. Muratech will supply the hanging bag to the project owner, engineer, or contractor. These bags will be fabricated from the same geotextile that is used for the full-size geotube. A suitable frame will be required from which to suspend the hanging bag. A painter's scaffold is preferred. However, a wooden frame at least 80 inches high will also work. Prepare the hanging bag to be suspended and place it in the frame. Once the hanging bags are suspended, place the 20-gallon containers underneath each bag. These containers will be used to catch the effluent water that flows from the hanging bag when they are filled and as they dewater. 40 gallons of sludge should be collected in 5-gallon pails from the source of the sludge or sediments that is to be dewatered. If there is any indication or question that there may be any contaminants in the sludge or sediments, such as heavy metals or PCBs, the material should be tested. A qualified environmental or geotechnical lab should be selected to determine the type and parts per million of each of the contaminants. For many dewatering projects, it will be necessary to use polymer to accelerate solids coagulation and precipitation and to improve the clarity of the effluent water. Your polymer supplier should conduct bench tests on the collected sludge or sediment to determine the appropriate polymer and dosage that will yield the most efficient and economical geotube dewatering results. Your polymer supplier should be given complete disclosure of all the contents of the sludge. The supplier should also have dewatering experience with this type material. Once the bench tests have been conducted and the polymer is selected, pour the 8 5-gallon pails of sludge or sediment into the 50-gallon trash container. If the sludge sediment sample is not at the percent solids at which it will be pumped or dredged into the geotube in the full-scale operation, water from the site should be substituted for a portion of the 40-gallon sample to adjust it to anticipated percent solids that will be in the full-scale operation. Record the exact total amount of material that is poured into the 50-gallon container and the percent solids of this mixture. Once the 40 gallons of sludge or sediment has been poured into the 50-gallon container, begin to agitate the material so that the solids are evenly distributed. Sample the mix for laboratory analysis and comparison to the material in the full-scale project operation. Now it is time to pour the polymer into the sludge and to mix it thoroughly. The amount of polymer that is to be used is calculated based upon the bench tests that were previously conducted. Once the sludge has been thoroughly mixed and the polymer is evenly distributed, you should notice that the solids are beginning to coagulate. It is time to pump the mixed sludge into the hanging bags. This can be accomplished with either a submergible electric pump or a gasoline motor-driven pump. All of the sludge should be pumped from the 50-gallon container into the hanging bags. Any sludge remaining in the 50-gallon container can be poured into a 5-gallon pail and then poured into the hanging bag. It is important to pour all of the mixed sludge from the 50-gallon container into the hanging bag. You will notice that as soon as the sludge is pumped into the hanging bag, the effluent water will begin to come through the surface of the bag. Collect effluent water samples at 1 minute, 10 minute, and 1 hour after completing the filling of the hanging bag. These samples should be tested to determine the percent solids in the effluent water. Also, it is important to collect all the effluent water that is discharged from the hanging bag in the 20-gallon containers and to record the total amount collected over the period of the test. This will help to determine the percent solids that can be achieved in the full-scale operation. After the first 24 hours from the start of the test, a port should be cut into the hanging bag at a level above the retained solids so that a sample of dewatered sludge can be removed. The sample should be tested by a qualified lab to determine its percent solids and specific gravity. This process should be repeated after 7, 14, and 21 days. This will be necessary to determine the effectiveness of the geotube dewatering technology. Once the hanging bag test has been completed, it will be necessary to dispose of the bag and the dewatered waste. If the dewatered waste has any contaminants, consult your local regulators for disposal methods. Now that the hanging bag test has been completed, data collected, and samples tested, you should be able to determine the effectiveness of the geotube during the full-scale operation by predicting 1. The quality of the effluent water, 2. The percent solids that can be achieved, and 3. The unit weight of the dewatered sludge. Now that you have viewed the complete hanging bag test, let's review all of the steps. Assemble all of the equipment necessary to conduct the test. Collect a 40-gallon sample to be dewatered. Set up the frame and suspend the hanging bags. Conduct a polymer bench test. Pour into and thoroughly mix the 40-gallon sample in a 50-gallon container. Blend the polymer into the sample. Pump the complete 40-gallon sample into a hanging bag. Collect effluent samples after 1 minute, 10 minutes, and 1 hour from start of test. Collect, measure, and record total quantity of effluent water. Collect dewatered samples for testing. Dispose of the remaining sample and hanging bag. Now you should be able to conduct a successful hanging bag test.